talk about what are properties of exponents. Well, we have our cute, kind of dumb but cute little song. Let's sing it. When you multiply you, when you divide then you, raise a power to a power and you multiply. Right, everybody? That's our little song. Now, when can we use properties of exponents? When you have, absolutely, say it louder. Yeah, you.
When the base is the same.
When the base is the same. Now we're talking base has to be the same to be able to apply properties of exponents. So if we have a to the n and we were timesing a to the n, are those the same base? Isn't this our base? Yeah? So those are the same base. So could we do a to the n times b to the n? Do we have the same base? No. So properties of exponents don't apply here. Okay, first couple examples, you don't need to be taking notes. This is all review. Just watch, then I'm going to let you practice. Here we go. Looking at these first few examples here, we have x to the 7th times x to the 3rd times x to the negative 2. Are we multiplying the same base? So what do we do with our exponents? Add them. So 7 plus 3 is 10 minus 2 is? So we have x to the 8th power. Very good. Questions? Let's do another one. 10 to the 7th times 10 to the 3rd times 10 to the negative 2. Do we have the same base? Does the base change ever? Did our base change here? No. So does our base change ever? No. So what's our base? 10. And we were multiplying base 10. So what do we do with the exponents? Add. So 7 plus 3 minus 2 again is 8. So 10 to the 8th. This would be rewriting it as one base. Any questions? Don't double dip. 10 times 10 times 10. If you did 10 times 10 times 10 and that was your base, you just changed the whole problem. It was base 10. We could add our exponents because we were multiplying the same base. The base part doesn't change. Are we all comfortable with that? Okay. Do 1 and 2. So this is how it works in my classroom. Check to see if the people, you try it by yourself first, then you check to see if the people around you got the same answer, then you check with me. Ready, set, go. Okay, so let's go ahead and write the simplified form of each expression. First thing we do, is there any addition or subtraction in here? Is there? No. So we're just multiplying all these things. So technically we have negative 3 times x squared times 5 times x cubed. Now with multiplication, can't we reorder it in any order? So I'm going to go ahead and do that. I'm going to put things that are alike by each other. Some numbers are alike, so I'm going to do negative 3 times 5. I'm just reordering it. And then we have times x squared times x cubed. I just reordered it. Any questions? Now simplify it in pieces. Now do not add those things. These are numbers. Multiplication didn't magically become addition all of a sudden. This is literally negative 3 times 5. Negative 15. Now this is the same base, and we're multiplying the same base. So what do we do with our exponents? Add 2 plus 3. So negative 15 x to the 5th. Any questions? Do I need to flip this over a fraction?
Yes.
Yes or no?
No.
Why do you say no?
Because the exponent is not negative.
Beautiful. So I get why you said yes, because we had a negative in front here. But remember, we only flip if it has a negative exponent. Very well said, Brendan. So the exponent you said was positive, so we don't flip it. Awesome. Okay, next one. Looking at this one, it's just multiplication, so I'm just going to reorder it. So I have 2 times 3. I'm just reordering it, and then I have an x squared. Then I have an a to the negative 2. Just reordering it, and then a to the 4th. Simplify in pieces. 2 times 3 is 6. X squared, no other x's. And then we're multiplying the same base here, so we... How'd you get that?
Multiply, yeah.
When you multiply the same base, you add your exponents. So negative 2 plus 4 is 2. All right, any questions on that? We all comfortable? Okay, 2, 3 through 4. Ready to go. So this next piece, first of all, when you have some base raised to a power and you raise it to another power, then you multiply. Okay, now here was the most common error on the final exam. If you saw something like this, 2x squared all raised to the 3rd power. Notice how I said it's all raised to the 3rd power. People ignored the 2. They pretended like 2 wasn't also raised to the 3rd power, and it is. So make sure you're really careful. So really we have 2 to the 3rd. Does everybody understand that? And then we have a power raised to another power, so we multiply. What's 2 times 3? 6, right? We multiply. So 6. So then you would say, okay, well, what is 2 to the 3rd power? 2 times 2 times 2, which is 8. So 8x to the 6. Do we have questions? Okay, next one. This next one's a little bit harder, but remember, with something like this, you always simplify the powers being raised to powers very first. So look at this section. Aren't we raising a power to a power? So we multiply. So we have x to the -9, and then we still have this x squared being multiplied, and we still have x to the -1. Is everybody comfortable up to here? So then from there, we're multiplying the same base, so we add our exponents. -9 plus 2.
7.
-9 plus 2.
-7.
-7 plus -1.
-8.
So x to the -8. Is this answer acceptable?
No.
No. What will we do? Beautiful. We do the reciprocal, so we flip it over a fraction. So I draw my line, flipping anything with a negative exponent over the fraction, it's now positive. Now if you flip it, it becomes positive. That was another common error. I felt so bad for so many poor unfortunate souls on the final. They flip it, they have the right idea, and then they wrote a negative in there again on accident. But if you flip it, you just fix the negative exponent. That's the whole point. So on top, the top didn't magically disappear if there was a 1 left on top. So we have 1 over x to the 8th. Any questions? Are we all good? You're sure? Okay, a couple of last ones, and I'm going to let you work for quite a while. Here we go. W to the 10th divided by w to the 3rd. When you divide, then you subtract. Okay, so you subtract the top from the bottom or the bottom from the top? Top from the bottom. So we're going to be doing w to the 10 minus 3, which is w to the 7. That one's pretty easy, right? Okay, next one. Look at this piece. All right, so we're going to simplify it in pieces. First of all, my exponent on x is a 1. So what we have here is, I'm going to draw my line. We have x to the 1 minus 2, right? And then we have y to the -3, so y to the -3. And then we're minusing -4, right? Everybody? Are you all seeing what I'm doing here? Are you sure? So then from here, on top, so right now we have x to the, what's 1 minus 2? -1. What's -3 minus -4? Let's say you didn't know. Type it into your calculator. But technically we're doing cross the line, kind of change sign. I hate that saying, but I guess that's what we're doing here. We have 2 negatives, so it becomes a positive. What's -3 plus 4? 1. So y to the 1. Everybody comfortable up to here? What's your question? Any questions?
Why do you like cross the line change sign again?
I just don't, because it's like a saying instead of the math. It's 2 negatives being multiplied together would make them positive. Alright, so then we need to flip anything with a negative exponent over a fraction. Leave y alone, it has a positive exponent. So we have x to the positive 1 on bottom. So the pretty answer of this will be y to the first, which is y, on top, and on bottom x to the first, which is x. Are we all comfortable with that problem? Do 5 through 12. Ready, set, go. Okay, so scientific notation. So, first of all, scientific numbers have the form, it gives the number and then times 10 to the something power. So these are just numbers, but they're written in scientific notation. So we have this scientific number being multiplied to this scientific number. So really, this is just all multiplication. Now don't mistake those x's, those times signs for x's. Those are just times signs. With scientific notation, it's the only time we'll use a times sign instead of like a dot. Okay, so 2 times 10 to the second times 3 times 10 to the -4. Now, since we need to write our answer in scientific notation, this is the easiest way of doing it. Well, we can reorder this in any order. 2 times 3 is 6. And then don't we have the same base right here? And we're multiplying the same base. So we add our exponents. So we still are going to have a times 10. This is the only time I write my times sign like that. So we're going to have times 10 to the 2 plus -4.
-2.
-2. Questions on that? So we're all good with scientific notation. Okay, looking at this next one. We're multiplying all this stuff, right? Right?
Right.
Okay, so can I reorder this in any order?
Yeah.
Yeah, so I'm going to put my 2 in front times 3. Now, I heard a lot of people on accidentally getting a little bit caught up. There's quite a few of you in here that were thinking that 2 was connected to x to the 1/2, but remember it's not. This is multiplication, so it's not connected. So 2 times 3, I'm just reordering it. And then I have x to the 1/2 times x to the 3/2, just reordering it. And then I have times y to the 3/4 times y to the 1/4. Now we'll simplify it in pieces. 3 times 2, do not add those. Those are numbers that are being multiplied. 6. We're multiplying the same base, so we'll add our exponents. So we have 1/2 plus 3/2, which is 4/2. And then we're multiplying the same base, so we add our exponents 3/4 plus 1/4. Because we have a common denominator, we can add straight across. If not, we'll just do it in our calculator, change it back to a fraction. So this is 4/4, right? So you're right, then we would simplify it. 6x squared y. Right? We're all good. All feeling comfortable. Do 13 through 18. Okay, so write each exponential in radical form. So I'm going to ask you a couple of questions. Think very carefully before you answer. 2x to the 2/5 power. Is there any reason for me to believe 2 is raised to the 2/5 power?
No.
No, in fact, it's absolutely not raised to the 2/5 power, right?
Right.
Only x is raised to the 2/5 power. Isn't this technically 2 times by x to the 2/5 power?
Yep.
Okay, awesome. So now we can rewrite it in radical form. So this 2 isn't going to go anywhere. It's not under the root, right? So my 2's multiplied on the outside. This is roots are on bottom of our flower. Power comes from the top, from the sun. So it's a 5th root. Make sure you tuck that 5 in there nice and pretty. It's a 5th root of x to the 2nd power because power's on top.
Isn't it odd that you don't even need to write it to it's just
Only if it was a square root. Good question. So if it was a power, love that question. So if this was a square root, you're right. You wouldn't need to write it. In fact, you probably wouldn't write it. Good question. But since it's an exponent, yes. Okay, looking at this next one. Is both raised to the 3/2 power?
Yeah.
So they're both under the square root, and just like Braylon just said, we would not write the square root in there. And then we've got to put both 3 and x in parentheses, and they were both raised to the 3rd power, right, everybody? Everybody? If I didn't have those parentheses, it'd be incorrect.
Right.
Okay. All right. So do 19 through 23. Be very careful. Yeah. Okay, I'm going to do an example similar instead. So the square root of 52x cubed. First of all, is 52 and x cubed under the same root?
Yes.
Yes. So they're both under the same root. Is 52 and x both raised to the 3rd power?
No.
No, so you're saying they have their own powers. Yeah, right? So you're saying 52 is just 52, and we have an x cubed, but there's no parentheses around that because 52 is not raised to the 3rd power. But they both are under the same root. So we do need parentheses around all of them. And they're both under the same root. Roots go on bottom. So there's a 2 on bottom because it's a square root. And then remember what power goes on top to help us out?
1.
A 1. Because 1 won't change anything. Questions on that? So everybody try number 22 again. Here we go. Guys, I was so deeply jaded deep by how many people missed this on the final exam. I was literally blown away. Blown away. Like, or how many people missed this on the final exam? So we're going to re-go over it. What is the degree of each set? So looking here, 2x cubed plus y squared. What's the degree? 3. You always go up the highest, right? Are those two things being multiplied? No. So we can't add the exponents, right? So what's our degree on this one? 3. You go up the highest. So this one is degree 3. Does everybody understand? Okay. Now look over here. 2x cubed y squared. Are those things being multiplied?
Yes.
Yes. Now, technically, could we combine them?
Yeah.
Could you?
No.
No, they're not the same base, but could, for the degree, don't we say that it's degree 5? Yes. So when you multiply, you add. So this one, because they're being multiplied, you would add them. It's very important that you understand that. So this one would be degree 5. With our total degrees here, add up to be 5. Are we all good with that? Do not add these ones though. They're separated by a plus sign. Is everybody good? Couple more. Write the polynomial in standard form, then name the polynomial. Standard form means highest degree to lowest degree. Everybody staying with me. I can't hand you the worksheet if you can't pull yourself back to me. So what's my highest degree? 3x cubed. So we have 3x cubed, no other cubes. And then we have negative 6x squared, right? And then we have minus 2x. I'm writing it in standard form, highest degree to lowest degree, minus 4. Not making any signers. Is it in standard form, all like terms combined? Yes, now I can name it. We name it by the highest degree and the number of terms. So, highest degree is 3. What's the name for that?
Trinomial.
No, that's for number of terms. Good try.
3.
No, there's a cute little name for it.
Cubic.
Cubic. This is a cubic. And then there's 1, 2, 3, 4 terms. So what's the name for 4 terms?
Polynomial.
Good. Cubic polynomial of 4 terms. So polynomial, and you have to say that of 4 terms. So what if there was 2 terms? It's a binomial. What if there's 3 terms? Trinomial. Does everybody good with that? Monomial is 1 term, right?
Quadratic is to second degree.
Second degree, very good. Quadratic second degree. Fourth degree is quartic. 4 quarts in a gallon. 5 is quintic. And then after that, it's just 6th degree. All right. Simplified. I'm just going to let you work pretty much on that last page. I need you to look through these last few with me really quick. 2x squared plus 3x minus 3x squared minus 5. When you're subtracting 2 polynomials, you have to be careful because we're subtracting all of this. So I like to write in a -1 and distribute the negative through so that I don't have to worry about it. -1 times 3x squared. Negative 3x squared. Now, if you're not looking up here, you're the people that miss it, and it kind of makes me mad. So I need everybody's backs turned towards me. Not backs. Fronts. That didn't make sense. So we're distributing the negative. And then -1 times -5.
5.
Positive 5. And then can't I just drop down this front stuff?
Yeah.
Okay. 2x squared plus 3x. And then from there, because I distributed the negative through, I'm not going to make any errors. 2x squared minus 3x squared.
-x4. Yeah.
What is it? Think about it again.
Wait.
What is 2x squared minus 3x squared? Does the x squared part change?
Negative x.
No, we're adding things that's just combining an apple. Doesn't become an orange. Negative what? Negative x squared. Very good. -1x squared. Any questions on how I got that? And then we have 3x, no other x's, so plus 3x. And then we have plus 5. Is everybody good with how to do that? I expect you at this level to not make errors when subtracting polynomials. So you got to be very careful. All right, looking at this one, wouldn't we just distribute? It's multiplication, right? Multiplication is the only time we distribute. -2x squared times 3x cubed is -6x what? Good. Very good. -2x squared times positive 2x.
1. X.
-4x what? Cubed. And -2x squared times -1.
2x squared. 2x squared.
Positive 2x squared. Very good. Do we have questions on that one before I got anything? Okay. Do 25 to 29.